Hello everyone and welcome back. Today we will continue with executing external commands. As you remember, we had our shell loop, we are passing our input, we are executing our commands, and these are our built-in commands. I can just say make, and I can say my shell, let's say echo hi, we say hi, and we have some built-in functions that we know. We implemented some which and other function. That's weird, I will check it later. Now I want to implement how we can execute binary functions like ls or cat or others. In this case, I will create a new file called executor.c. We will use this for our external we will use this for our external commands. We will use fork, and if you don't know what fork is in the Linux manual page. It creates a new process by duplicating the calling process basically, and it creates child process from calling the process from the parent process. Basically, we are calling a function inside of our function, if I want to say simply. And you can check in the gigs for gigs some implementations, examples of fork. Basically, you create a PTP and you create a fork, and then you give it an ID, and it just runs same time as your current function or program. Let me see. For example, fork example. We are having pit, we are calling it fork, and if fork doesn't fail, it says hello from child as hello from parent. Yeah. Basically, it helps us create a new child process from the parent process. That's what we are going to focus on. So I will just write a short command saying executes a command by forking and running it in a child process, which will have an integer return type. I will call it executor. It will have char star arguments, and it will have our environment. And do I have it on my shell executor? Copy, paste in the main, same again. Let's stay like this for now. It will return executor, not a building command. Execute as external command, and let's go to executor. So as you seen in the here, I think which one was more Yeah, we will have something like this actually. So I will say for pit t pit, we will have pit t pit, and we will have status, and pit will be fork, and if pit equals -1, we will say per fork, and we will return 1 for exit. We don't have pt, and for pt we need one of these. Which one I'm missing? stdio, stdlib, std, and system types, I think. I don't remember which one was this for. Do we need this? Seems fine. Helpers, fine. We can say 1. Okay, I don't think I can even need this, so I'm gonna delete. I'm trying to keep our library at minimum because it's our own implementation, no need for extra libraries as much as possible. So let's go back to executor. So we are calling pit, we are assigning it our fork, we are checking if it's forking or not, and then we will say if pit equals 0, which means return value on success, pit of the child process is returned in the parent, and 0 it is returned in the child. Yes, if it's successful it will be 0, on failure it will be -1. So that's what we are checking for. If it's -1, it means there's an error. If it's 0, it's returned to the child, so that's what we want. And then we will need a new function called int child process, which will have child star arguments and child star nv as usual, and let's give it an explanation. Attempts to execute the command by searching paths and the current directory. So basically when we say ls, it executes, but how does it know what to execute? So we are going back to story, like when we say which ls, basically our program will search in the correct directory the binaries, and when it finds, okay, I found the binary, I know its location, I know where to execute it, so I can execute it finally. That's why we need to like search and execute. And if pit is 0, we will call our child process, which will have args and env, and did we add it to the shell? Let's add it. Okay, we have our child process, and it will return, successfully or fail, so we can check. If it returns 1, it will be fail. So if this is 1, if this is 1, we want to say power execve, because we will use execve, and we will return 1 as our error code. Child process, and we'll say else. In this case, parent process. We will have if, and we will check in the parent process if our pit is successful. So there's a function called wait pit, which will get the pit and status 0 equals -1. I made a typo. Wait pit. If you don't know what wait pit is, you can just Google and check. Wait for process to change state. It will basically get our pit. We have our status value. Executes a command by forking and running in a child process, and if it returns -1, meaning wait for any child process whose process group ID is equal to absolute value of pit. If it is -1, meaning wait for any child process. So if it's -1, we will wait for any child process. And then we will have error of wait pit and return 1. Don't make a mistake. Let's write it more openly. And if with signaled status so if you don't know, we can just Google with signals. It's process completion status, one of the status. It's in the system wait header. I think we already have it. No, maybe not. It's in the system wait. We are waiting for the child process to stop or terminate. We are checking if signal is the same status, correct status. In that case, we will say printf process terminated by signal %d new line, it will be terminated signal. It will have status. I think I am missing an header file. Or not, I don't see any errors, but do I missing a header file? Okay, yeah, it was in the right header file. So now we have the correct header file. We will check for status of our pip, and if there's a problem we will return 1. Alright, so our child process will attempt to execute the command by searching the paths. So we will have the path that we want to find and execute. So it will be get path and we don't have the get path function, so we will have it. And I will say char star get path. It will have char star environment as input, and it will basically check int I equals 0 and v of I exists I plus plus, and if str my str and compare is v of I, and its path equals 5 equals, then we will return my str duplicate and v of I plus 5. And return null in case of an error. So our getPath function will check the environment, try to find the path, and after finding the path, it fetches the path environment variable. This will get the path. So our path string will be get path environment. We will have int num paths, and we will have char star star path list. It will be also split paths. String, and it will get the num paths. Depends on how many paths we will need. So we will get the path string, we will check number of paths, and we will have a path list, which we will need to implement another function called split paths, which will be split the path string into individual paths, which will be char star star split pets, and it will have char pets and in star count. So basically in the child process we will have the pets and we will search in the pets what pet we need, and then we will try executing the command in the working directory, and we will check if execve works or fails. And that's why we call it execve, because we will be using execve to execute the program, the binary programs. Execve executes the program referred to by pet name. This causes the program that is currently being run by the calling process to be replaced with a new program. And we are basically having the child process function to successfully implement execve, which needs the pet name. That's why we are doing these functions. And so we will get the pet list. Let's implement the function. As I told before, it will split the pet string into individual pets, so we will kind of tokenize our pet. We will have a result and we will return result. We will have token and we will have pets copy, another string, but it will be our maximum pet length. Do we have it? I think we did check it somewhere before. Maybe. You can just Google max pet length, and Microsoft Windows has max pet limit of 256 characters. So you can say define max pet 256. It will be the maximum pet, which will be max pet length, and we will copy the pets into the copied pets. My strn copy, which we don't have it yet, so we will need to implement it quickly, which will have pets copy and pets and size of pets copy. Okay, we step back now. We will need to implement our strn copy function. I go to my helpers, I say, also I think it's time to give some commands to these functions too. I will be back in a second. Okay, so it will return a char star. I will call it my strn copy. It will have the destination value. It will get constant char star source, and it will get the size t of n, which will have size t of I. It will copy up to n characters from the source to destination, So I will say for I equals 0, I is less than n, and source of I not equals empty character. In that case we will go I++, and destination character will be the same from the source, and we will fill the rest of the test with null characters if source is shorter than n. So I will say for nothing to declare, I is less than n, I++, destination of I equals empty character, and then of course we will return the destination. Also I want to give them some length of the link, get env, I want to write some comments for this. Alright, I will just copy and paste some general declarations. My getEnv will search the environment variables for the specified name and return its value. That's what it does. My str duplicate creates a duplicate of the input string by allocating new memory. Allocating is important, so we need to free it when we used it. And str copy, this is self-explanatory, but I will say it again. Copies the content of the source string into destination string. My str character locates the first occurrence of a character in a string, finds the location of the character we are looking for. We have my str token. It tokenizes the string by splitting it based on a set of delimiter characters. Guess the tokens. And our last function copies up to n characters from the source string to the destination string, ensuring null termination. Null termination is important. So we are going back to our executor and in the executor we were working on our split paths. So now we have a str copy. Oh, we need to call it okay, so it's in the header, so I think we can see it now. Yes, we can see it. As it says, copies up to n characters from the source string to the destination string. So our source is pets, destination is pets copy, and we will give it size of pets copy. And pets copy size of copy -1 is equal to end. So we are making sure we really end our pets copy of the pets, and we will have our token. It will be my str token. Now it also has its explanation, which is much better. And as you can see, we will give it the input string. We will say pets copy, and we will search for executable, and we will count. We will be counting. So when I say NV, and we are looking in, like, for example, here, let's be more specific, path equals, okay, let's say this is path equals so much data, and they are each a path of something, and they are divided by periods, as you can see. So we will check for paths, tokenizing them by using the period count, and we will say while token exists, we will have the result, which will be the allocated place for count +1, always +1 for the end of the string, and we will have size of char star. Okay, we will reallocate the result. It's important. We are using C. We don't want segfaults or memory leaks when we are done with this. If not result, we will say per realloc. It's possible to have allocation problems, and we will return 1 if result count, address of count equals my str. What's the problem? That's weird. str dop. I don't have an str dop. Come on. Yeah, it's here. What's the problem? I think it happens sometimes, like it just doesn't want to. Maybe I'm having a connection issue. I will restart. The code space, maybe there's a problem with the code space. It happens sometimes. When you use virtual machines and server-based operations, programs, they sometimes fail or froze, so you just need to restart. And yes, now we have it working. What were we saying? And we are copying our token in the index of result count. And we will check if it is valid or not. If not, result of address to count. I mean, if it's not existing, we'll say print error str dop, but my str dop, to be more specific, I think I also need to change this in some place else, and we will return 1, and the count can increment, and token will be my str token. We will initialize the token, and we are already returning the result, so I think this should work. Let's try. I will say print f pet %s pet list of I. We don't have an I, so let's have an I. For int I equals 0, pet list I exists, I plus plus. In that case we will print this. Let's say make problem. What's the problem? Executor. Did I make a mistake? What's the problem in function shell builds? Undefined reference executor. Huh. Because we forgot to add our executor to our make file. Okay, this is more likely. Okay, so what's the problem in executor? Hit 1. Null if there's a problem. Null make executor split pets. Pet function functions. We will have get pet. We will have split pets or pet functions. I say make again, and in this time we have unused parameter. Which one? It's x. So I can just let's say void x for now. Make finally my shell. What were we doing? We were saying like ls process terminate by signal 11. Okay, why that did terminate? We are looking for x environment. In parent process, it's failing. Oh, I don't even call the child process. We are going straight to the parent process. That's not what I was expecting. Let's check quickly what's the problem. And okay, I will do the error handling later. I don't know what's the problem now. I think I am missing something. Again, it happens. So first I just want to see if our child process is working or not. So I will call it anyways. Let's make my shell ls segmentation fault. Interesting. Now I'm curious what's the problem in my call the child process. It gets the pet, which should be working, and returns the pet to the strings. Maybe I need to free them. Pet list and free pet string. Let's try again. My shell ls segmentation fault. Interesting. Why is that? I think we are having a problem in this function, because we give it the address of number of pets, but we don't have the number of pets. But initializing it here. Address of the count, and we are assigning the address of the count 0, and we are counting by the address, so we can modify it all over the functions. Okay, I will do some debugging. Okie dokie, I found the problem. So if you remember, when we were checking the split pets, we were getting the maximum pet as our value, which was a mistake. So I'm just gonna delete this, and instead of that I am giving the length of the pets. This way it's working. I did put some printf statements to see the problem, like what is the problem. But as you can see, now we are getting all the in the child process we are successfully getting the pet list, so we can delete this statements. I will uncomment this. Let's see, make my shell, if I say ls, everything works. This again, my shell ls, let's see. This is not the function, I'm just testing it. In the child process we are getting the pet list, and it gets all the pets from the environment pet, and it splits successfully, it prints, and we are of course freeing it, because I think I also forgot to put this previously. Our split pets function is working, get pets is also working, and we can continue in the child process. Let's say execve. because we don't return anything, so of course it thinks there's an error. But if I say make my shell ls, it's working, I guess. So okay, let's continue on the child process. Okay, so now we will use two functions, which will be access and execve. Access will be used for so we can access the path and binary we want to execute, and execve for executing them. By the way, this is also concurrent programming. Yeah. So in the parent process, we are calling a fork, and it happens concurrently. Is the child process and parent process happens at the same time. That's why we were saying wait pit. Yeah, we are waiting for pit to conclude, and then we are continuing our parent process. But in the child process, let's have a for loop. Int I equals 0, I is less than number of paths, I plus plus, and we will have a full path. The full path will have the maximum possible length for a path. I think that's why we were in the 256, because I think this time it should be correct. So maybe I didn't even need to do this. Let's see, max path, because the problem was I was having multiple paths and storing them in a small container size of 256, but I think this should work, because maybe not, I don't know, I might need to, yeah, let's give it a bigger value, let's give it maximum input. I am not sure, and it shouldn't be a big problem. Okay, so we have our full path. We will use sn printf function to give the full path. It will have the size of the full path, and we will give it %s / %s, which will be the path list I, the path, one of the paths we are looking, and the argument that we are looking for, argument 0. And if we can access the full path, and I think it was X, okay. There's a list for this, but I did check it before. So if we can access, we will execute execve, and it will be full path x, and you can see when I check access, it's test for access to name using the real UID and real GID, and execve replaces the current process executing path with arguments argv and environment MVP. We give it our full path, the argument we want to execute, and the environment we want to check and execute. And I would say this should work. After that, of course, we need to free the path list, which I do it outside of that for loop. Maybe we can do it in this both for loops, but it's okay. Okay, let's check my shell ls. Nice, it's working. Success, first time. If I say I don't know, cat, never mind, my shell cool, we can execute in the external commands in child process. Can I do it more experiments? Yes, I can even say lsl, which is cool. We can also test the cat command. I created a new file .txt called blah blah. This is a file. I will say cat file.txt, and it prints the contains containers of the file blah blah. This is a file. Nice. ls is also working. What we use binary executor in executor.c. Let's see, we will need to add some stuff. First I want to add something important. I also want to check for if w term signal status equals execve, which would mean if our okay, I will find it why. Fault. Yeah, if termination signal is same as execve signal sec fault v. What am I? In here, execve. Did I make a typo? This is supposed to work. Oh, okay. This was easier than I expected to be. And now another problem, of course. What if I put this in my header? I can't. This compiler path. Let's fix. signal is here. Okay, I don't think it will kill us if you don't have signal for segmentation fault. I can try to add this later. I will just comment it out for now. So let's continue our child process, and after we are accessing, executing and freeing our pet, I will, don't we need to print this anymore. I will try executing the command in the current working directory, in the sense of like if I want to execute something from my let's create a test.c, include stdio.h int main, printf hello world, return 0. If I say gcc test.c, we have our executable a. If I say a, we will have a.out. So if I call my shell, and if I say okay ls, give me what you have, a.out, I want to execute a.out, it cannot find it. Okay, so what we're going to do is we will find the command in the current working directory and execute it. So I will say char cwd, and we already got this a couple times before. I will give it the maximum input because I am tired. We will say get cwd, it will take the size of cwd equals null. We will have an error. I will say error get cwd, and we will return 1 char full cwd pet, which will also, again, I will give it the maximum input. I can give it extra because when there's an extra space left, like for example get cvd puts as end of line at the end of the char string, so sn printf, again I will give it full cvd pet, and I will give it the size of the full cvd pet, and we will have %s /%s, as long as, and it will have cvd and args 0. Very similar to what we did with the first part, which was getting the pet from the environment, but this time we are getting the path from so we can remove this. Yeah, we already checked for if it's an environment like a binary, and now we will check if it's in my directory. So we can just say execve, which will have the full pvd set arguments and environment, and if execve fails, we will say execve. I think this should work like this. Let's compile. Of course, there's a problem. Did I make smprintfs full cvd path size of that? And x0. I don't see my problem. In that case, what we can do is, let's check what we did before. For example, when we were looking for command cd, I think we were also getting cvd somewhere. We can do like that. I will say char cvd equals null, but of course it's char star cvd equals null, and we are giving get cvd and null. Buffer size, in this case it gets buffer and size. Equals get cvd. If it's null, we will return error. If I say make my shell ls, it works. What were we doing? We were looking for a out. Because out. Okay, doesn't work. What's the problem? Let's check my notes. we need to go into the child process, execute, ls works, dot, doesn't work, dot out, that's interesting. So first we are getting the path, we are splitting, and we are executing by accessing. And the second part, we are checking is in the current working directory, cvd. I cannot see my cvd. I think this is a problem. I was in the other one. Okay, let's change it to this. My shell ls works dot out. Nice. Now it is working. I made a mistake with the cvd. And full cvd path would be let's print it. It will be make my shell a dot out. Our cvd path. I think this is okay. Now we can even compile and run our own shell, like it will be a shell in the shell, like maybe my shell. Okay, maybe it doesn't work like that. First I will stop printing this. No need. Make my shell ls a dot out. If I say my shell, inside of my shell I will have my shell. Crazy. Interception kind of modes. Okay, so I think this is enough for this video. What we did was we were already executing built-in functions. Now we are also executing outside commands or binary commands, depends. We are using child process, we are using fork, and we are using child process to execute that fork. We have access and execve for accessing and executing the binary commands inside of the environment path. And we of course need to create them, and if it's not an binary command that's in from the path, we are checking the current working directory. In this case, like I have my a.out, which is basically says hello world. I can execute it from my shell using executor, and I think that's it for today's video. We had executor, child process, get pet and split pet functions. We also added str and copy, and we are mostly done in our shell. We just need to do a couple more things, and I think we are almost done.